Hello, today's video will be a review of the UT-120A digital pocket-sized multimeter. Um, in general, you know all too well that there are situations when a certain multimeter may be highly adequate and when others may not. In this case, I think the most important reason for buying such a product would be its very small size, and also I would add the ability to have a multi-ranging multimeter, actually an auto-ranging multimeter in such a small size. So we are going to take a look at how this multimeter fares compared with the UT-33C you have seen featured in so many videos. Alright, so if we are looking at the size, there is a noticeable difference, and I think this is going to be the most attractive factor. The fact that you have a multimeter that you can clearly place in your pocket and that it's also going to be safe, because as you will soon discover, this multimeter also comes with a casing, which means that it's entirely safe to carry it in a pocket and you're not going to have any issues with its safety. Alright, so let's unpack the product. And as you can readily see, you have a very nice plastic case. And also, and this is another advantage, you can also see the screen. So you can operate the device even in its protective cover, and you can take the probes out of the case in order to make the necessary measurements. And I think that all of these factors combined give a very good product in the sense of usability and also great portability. So let's find out how the multimeter actually fares. As you can see right away, you have the typical combination of buttons and a rotary switch. The rotary switch selects the range, while the buttons select various functions. You can also note the fact that there is no backlighting, and this may be a deal breaker for some, but not for others. I think that this feature might have helped. Unfortunately, I'm not sure how much of a battery drain it would be. Regarding the probes, because this is the next aspect you would like to have an insight in, the probes are very small. They are, however, having a good feel to them, so I think they are not going to break off that easily, and the strain relief that is placed on the end of the probes, I don't think is going to break that easily. However, we have to mention the all-important fact that if you look closely, you're going to notice the test probes and the cables are actually attached to the unit, which means that you cannot replace them easily. You don't have a particular connector that could be used so that you could change them on the fly, which means that you have to disassemble the product in order to be able to do so. Alright, so that is the first aspect we are mostly concerned with. Alright, in terms of battery, it requires a CR2032 battery, which means that it's quite compact, and I think you might have some of these batteries laying around, so I don't see any problem in making sure the device operates. Regarding the ranges, it has auto ranging in the DC voltage and AC voltage, as well as the ohm meter range. It also has the ability of determining the actual frequency of a given signal, though I'm not entirely sure if it's going to be presented with too many details. Okay, so if you look at the specifications, 100 kilohertz, but we don't know exactly what is the typical accuracy in that range. So probably don't expect it to be a good frequency counter. All right. The rotary switch feel is quite nice. I don't have any complaints about that. The device starts quite quickly. It starts in the volts range and actually starts in the or 4 volts range. I think 4 volts range, because it's a 4000 count multimeter compared with the UT-33C that is only 2000 counts. And it will change the range automatically. I think that this is the first range, and then you will have probably the 10 volts or the 40 volts, I think the 40 volts range, then getting to the 600 volts range probably. Yes, I think that's the case. And you are probably mostly out of the abilities of this device. The fact that you cannot measure more than 600 volts, I don't think is a major issue, because with such a device you're not expecting to have any sort of servicing at more than that. I think it's not a bad idea that you have the AC voltage range separately on the rotary switch, because it's much more obvious when you have to operate the device. And also an interesting addition, and one that is particular to newer models, you have the ability of creating or setting relative measurements, which would mean that when you're going to check a particular voltage or a particular resistance, you can zero in the multimeter, and then any deviation above or below that value is going to be registered from that value further. So that is going to be your relative zero. And I think this feature is highly useful, particularly on the resistance range, when you may want to see how much a particular component deviates from your expectations. And there is also the possibility of setting manually the range, measurement. For instance, if you want to switch from AC voltage to hertz, you could probably press this button and you would see what kind of frequency it detects. In this case, I think that the reason it picks up 50 Hz is because there is some sort of capacitive coupling, because as you can see, if I leave the probes totally out, we don't see any sort of frequency measurement. Alright, let's see if I can find a way to decouple. Anyway, let's move further and see also the ability to measure diodes, probably the reverse voltage continuity, which means that it also has a beeper, as the sign suggests. And there is the other off position. You may wonder, what's the use for two off positions? I think the reason is that the rotary switch had more positions, and they didn't want to have two separate ranges, one other separate measurement range, because the UT-120B has also the ability of measuring capacitance, and I think that this would have been in the place of the second off position. Alright, let's see how it actually handles certain tasks, but before, let me mention again, a 4000 count multimeter means that it has more range and probably a bit improved accuracy to one that is 2000 counts. However, you always need to take into account the actual ability, not only the display count possibilities. And in this respect, before getting to actual measurements, as you can probably guess, we have around 0.8% accuracy plus 0.8% plus 1. And in the case of UT-120 UT-33C, we have an accuracy of around, let's see, 0.8% plus 2. So it's similar. The difference is that +1 in the case of UT-120A and +2 in the case of UT-33C. So I'm not expecting major accuracy difference. When we are going to the AC voltage range, we see 1.2%, and the other multimeter, the UT-33C, is at 1.2% plus 10. This one is 1.2 plus 3. So a bit of an improvement in the AC voltage measuring capability. The resistance measuring capability is going to be massively improved, because instead of 2000 counts you have 4000 counts, which in this case translates from maximum resistance measuring capability of 20 megohms to 40 megohms. So if you have high resistance measurement, this may mean something. On the other hand, keep in mind that there are multimeters that have a range of around 100 or 200 megohms, so this is not going to be entirely useful. And I think that right around 30 minutes, I think that we are talking about the device power off feature. From my perspective, this is a bit high. I was hoping for 10 minutes, particularly with such a low battery, but it doesn't matter. And it can operate probably at 2.4 volts, and while a new battery is around 3 volts, so not a bad device nonetheless. 76 grams, so it's very light compared with the other one that I think is around 150 or so, double at least that weight. Alright, so let's see how it handles certain measurements. So let's power on both devices and start our measurements. Okay, we are going on the 20 volts, or actually on the 2 volts range, because this will show exactly what we are facing. This one can go up to 2 volts, so it's 1.999. This one is 3.999. So the measurement accuracy is not going to be massively different, but it should be something that we will be able to see. Okay, 1.514, which is a good accuracy in my opinion. $1.520. There is a bit of a deviation between those two meters. I'm leaning more towards the accuracy or the value being read by the new 120A multimeter. In practice, this is what happens. I will also give the indication if this is the actual situation with a more accurate meter. Let's move to another measurement. This battery that should have around 8 volt. .04 volts, and in the case of the other meter we are seeing around 8.04, 8.05. So I'm expecting both multimeters to have the same accuracy, and this is very good. Alright. Next on the list we have AC voltage measurement, and I'm going to plug both meters into the mains, but first make sure that we are on the correct range. Alright, so let's see. I'm expecting around 230 volts or so. $228, so it's quite close to what I was expecting. And right now we are on the correct range. Let's see. 220. 26 or 27. Keep in mind that the value may jump a little, so a deviation of around 1 volt or up to 5 volts is not uncommon. So 227, this is quite close to what we measured before. And actually, the mains voltage changes from 1 second to another based upon what happens on the network. So actually don't expect the AC voltage measurement capability, at least in this scenario, to be truly relevant. All right, let's get back to other measurements, and I think that we will be checking the ohm meter. Okay, I think 2000 ohms may be good, though we will see if this is the situation. Okay, 554 ohms for this small variable resistor. And let's check the same value with the new multimeter. $458 or so. Yes, 456, 457 probably. It's within the margin of error, and I'm not expecting this particular resistor to have the necessary accuracy. It's just a point of reference for those two devices, meaning what you can expect if you measure the same value with one and the other is not as if this would be a high accuracy component. What you have noticed during testing is that it takes a bit of time for the multimeter to get into the desired range, which means that you have greater latency when operating the auto-ranging multimeter than when you're operating the classical one, and this has been noticeably higher than in the case of voltage measurements. So you should keep that in mind when you're making quick tests. All right, let's also see how it handles the diode test. And in this case, I took a fast recovery or a Schottky diode. Okay, in one direction, in one polarity, it should measure 0, and in the other it should measure a specific value, in this case 464 volts, which is all right. Let's also move into the continuity and diode test with the other device, and as we are seeing right now, 576 volts. I'm expecting this value to be less accurate on the older multimeter. Unfortunately, we don't have a reference in this case of what the meter actually does. We can make a cross comparison, but I'm not entirely sure if it's going to be meaningful. All right, let's make an attempt. Alright, so the old multimeter sends around 3 volts when it makes these measurements. Let's see how much the new multimeter sends when it's on the same range. Okay. And it sends around 0.52 volts. No, 1.52. So I think the values are quite close, but they are not the same. Which means that I'm expecting this variability not to come from the multimeter's capability, but more from the voltage that is being sent into the component, and this means that the component may behave slightly different. Which one is better? It's hard to tell. I don't have enough experience in order to know what is the best case, the best test case scenario for diodes. But what matters is that those devices handle it differently, one compared with the other. And one other aspect I would have liked to test is how well you can use the manual ranging feature. As you have noticed before, I was not able to change the range without measuring a specific value. So let's see if this one can be done. Okay, it cannot be done, as you can clearly see. Let's also measure another battery and see if I can change the range. Okay, you cannot change the range. So the idea is very simple. If you require your multimeter to have manual range, as most of the devices in a similar form factor to the UT-33C do, such as the UT-33A+, this multimeter cannot do. So you cannot change the range manually. You have to rely on the automatic ranging that is being done. From my point of view, this is a minor nuisance, because when you are expecting certain values, you should have the ability of having a manual ranging, because in this case subsequent measurements would take less time and the device would not require this delay. Unfortunately, this is the current situation. All right, let's see one other aspect I would have liked to show, and that is the relative measurement, and see how well it operates. Okay, I think this will do. So 1, 2. Okay, let's see the other one. Zero 6 megohms. I think that something is slightly off. Okay. Let's make another attempt at having a proper you can see that it's very slowly auto-ranging itself. So 0.456. Let's make a relative measurement out of this. And then let's place let's change the measured value. So it's 0.200 ohms below that value, and it dropped. Anyway, what matters? You can use the relative measurement and you can have very easily the ability of checking how much variation is between some components, and I think that this one still stands as a highly useful feature. I'm not entirely sure if you can make the same relative measurement on the DC voltage range, but let's find out. Okay, we are going to measure our battery, and we have zeroed it in, and when we are going to measure the other battery, we are going to see that the value is dramatically lower. So I'm expecting a minus sign and around 6 point something volts. 9.56, yes, so this means that the relative measurement is not available on this range. I think this is a slight nuisance, because I was expecting the relative measurement to work also on the DC voltage range, not only on the ohm meter, but unfortunately this is how the situation stands. I will also make another attempt, just in case I made something wrong. Okay, 0 it in. I wasn't expecting the multimeter to hold the previous value in mind. I think this is a bad design decision. I should have used the hold function in order to have this voltage in mind and not have the relative value being the last value being presented on the meter. 9.55, 6.53. All right, so it actually takes into account that value, but it works slightly different than I would have expected. For instance, in this case, I was expecting a 0 value instead of 1.51 being shown, or the last value that was stored in order to make the relative measurement. All right, so it actually can do relative measurements both on the DC voltage and on the AC voltage range. So I think this one is very useful. In the case of AC voltage, I could make another measurement, but it's not going to be entirely surprising. All right, AC. And if we're going, you can see that it's almost at 50 Hertz, which was expected. And if we are going to another measurement range, we can see that you have the same capability of measuring the value. In this case, I'm not entirely sure if it was a good design decision or not to have the frequency measurement on the DC voltage and AC voltage, and having it as well as a separate measurement possibility on the rotary switch. I think this is not a deal breaker, but sometimes it may be slightly confusing. Anyway, overall, what I do think about this multimeter. I should have mentioned something about the price, but you might also have seen it on the specifications, on the video details. This product retails at around 15 euros or $20. Of course, if you find a good deal. I'm expecting it to drop further in the future, or at least keep the same value, but not be any meaningfully expensive, because ultimately it's a small multimeter, it's a simple one, and while it doesn't have the other features, I think it's a wonderful addition for persons that want to have highly mobile experience. And I think that it does so quite well. There are some small nuances about the way it operates, but nothing that I consider to be a deal breaker. And unfortunately, while the test prods and cables are attached to the unit, I'm pretty sure that you can find a way to change them, and this may not be such a big issue. On the other hand, what I found to be slightly annoying is the fact that you cannot change the range on the DC voltage, AC voltage, or ohm meter in order to have better control over the values. But I think that this is not going to be a factor that detracts from a purchase. So if you need a highly portable multimeter, one that is of course much easier to carry in your pocket than the standard multimeter size, I think that this one is pretty good. And also keep in mind that there are other multimeters that still have the same or a roughly similar capability to this one. They still have a rotary switch, but they don't have the auto ranging feature, which in a pocket-sized multimeter, I think it's an advantage, because you may sometimes simply place the device in the carrying case and carry on with your measurements, not having any sort of need to open the case and change the range again. So I think those features are actually quite good, but I would have enjoyed a bit more flexibility. Other than that, perhaps you cannot do as much as you can on a typical multimeter. In this case, you notice the noticeable absence of a DC current or AC current measurement capability, which was possible on the UT-120C. However, my recent experience with an UT-120C has been somewhat annoying in the sense that it doesn't have a very good self-calibration capability on the DC voltage range, which means that I don't have that much confidence in the other aspects that I would like to determine with it. So ultimately, the UT-120A, which is also priced lower than the UT-120B or 120C, I think is a device that has a reasonably good set of features, and it retails at a price that I don't see any problem recommending. So ultimately, I hope you enjoyed the video. Thank you very much for watching. And if you thought about looking for a pocket-sized digital multimeter, I don't think you would go that much wrong by choosing an UNI-T UT-120A.